All right, we're going to go ahead and start on section 2.2, not 3.4. This is a boo-boo in my notes. So if your notes say 3.4 right there, you can mark that out and just replace it with a 2.2. Sorry if that's confusing. All right. So we are looking at reference angles for any angle that we write in standard position. Okay, this is going to help us to determine what reference triangle we need to use. So remember in the last section, we talked about a 30, 60, 90 triangle and a 45, 45, 90 triangle. So those are nice angles that we know how to find the trig functions of. So what we want to do is be able to draw these angles in their standard position so that we can then figure out what reference triangle we would use for it based on if it's a 30, a 60, or a 45. So let's go ahead and jump into it. Let's look at A. We're looking at a 30 degree a 30 degree angle measure. So remember, here's 0 degrees, here's 90 degrees. If we want to draw a 30 degree, that's going to be a third of the way to 90, right? So that should look something like this. That's a 30 degree triangle. Okay. Now, luckily for us, 30 is already in this first quadrant. It's a nice acute angle that we can see from the x-axis is a 30 degree angle. Okay. So when we're looking for our reference angle, which is what we're focusing on here, our reference angle is in regards to our x-axis. Okay, meaning if I were to draw a triangle using the x-axis as my adjacent side, what would this angle measure be? Well, it would be a 30 degree triangle, right? I keep saying triangle. A 30 degree angle. Okay, let's look at another one. Let's look at negative 30 degrees. Okay, negative 30 degrees means I'm going to go clockwise. Okay, so here's where 0 is. Here's where negative 90 is. So we're going to go a third of the way, which looks something like this, right? So notice if I were going to draw a triangle on this one, using the x-axis as my adjacent side, this little angle measure here would be a 30 degree angle. Okay. I'm not taking into account the negative because I don't really care the direction. I just want to know when I draw my triangle, what is the angle measure that is coming from the origin and creating my triangle. Okay. Let's look at another one. Let's look at B, 150 degrees. Okay. Well, 150 degrees is going to be somewhere between 90 and 180, right? So if I go to 90, and I need to go to 150, that's going to be an extra 60 degrees, right? So 150 minus 90 leaves me with 60, so I need to go another 60 degrees, which is going to put me over here, right? So this angle is my 150 degree angle, right? It's 60 degrees, this little distance right here, right? It's 60 degrees past 90. So this is how I draw it in standard form. Don't write that 60. Here is my standard form of this angle, right? But I want to know its reference angle. So its reference angle is the angle I get when I draw a triangle down to the x-axis. So if I draw a triangle down here to the x-axis, notice if this was 60 degrees, I only have 30 more degrees to go until I get to 180, right? So this little distance right here is going to be 30. So this is also got a 30 degree reference angle. Does that make sense? It's whatever the angle is that creates the triangle down or up to my x-axis. Okay, we're always making the x-axis the terminal side. All right, So let's look at another one, negative 150. So negative 150 is going to go in the clockwise position. Same idea. This would be negative 90. This would be negative 180. So again, we're going to go over here and we're going to go 60 degrees past negative 190. So it looks something like this. This is a negative 150 degrees. But remember, we're looking for the reference angle. The reference angle is the angle we get to create a triangle using the x-axis. So this angle right here on this reference triangle, remember 150 went 60 degrees past 90. So that only leaves 30 degrees here. So this one also has a 30-degree reference triangle. Okay. All right, so there's two more to try. I want y'all to pause the video, see if you can draw the angles for 210, negative 210, 330, and negative 330, and determine what the reference angle is. Okay, if you get stuck, or if you finish and you just need to check yourself, unpause the video and we'll go through it. Okay. Okay, let's see how you did. So on 210 is going to go past 180, and it's actually 30 degrees past 180. So here's how I draw my angle in standard position. And then looking at this little triangle that I've created, since I'm 30 degrees past 180, this also has a reference angle of 30 degrees, right? When I do 210 in the clockwise position, because it's negative, again, I'm going 30 degrees past 180, but this time it's going to be up in quadrant 3. So again, because I'm 30 degrees past 180, this is also a 30-degree reference triangle. I feel like we're getting a pattern, huh? Okay, and then on D, same thing, 330, that's almost one full revolution, right? Or one full rotation. So 330 degrees is going all the way around and stopping just a little bit shy, right? Because one full revolution is 360. So if we stop at 330, we're actually stopping 30 degrees shy of that full revolution, which tells me that this is a 30-degree angle, okay, reference angle. So standard position angle is what we have written, right? And what we write on here, whoops, I forgot to write mine. 330 degrees, negative 330 degrees. That's our standard angle. Our reference angle is the angle that shows up in our little triangle wherever that angle ends up being. Okay, so negative 330, I go in the in the clockwise position, and I stop just 30 degrees shy of a full rotation. So again, this is a 30-degree reference angle. So notice what this is showing me is I have all these different angles that all end up with the same reference triangle, okay? And so now that I know what that reference angle is, I should be able to find all the trig function values based off of that reference angle, okay? So let's go a little deeper. Now, all of those ended up being 30 degrees because I want to show you there's a bunch of different ways to get the same reference triangle, but it won't always be 30 degrees, right? We hope that it's 30, 60, or 45 because we have nice triangles for those. But sometimes we'll get something a little wonky. We'll get a different reference triangle or a different reference angle, okay? So let's look at something like that. If I want to find the reference angle for 294, okay, well, here's 90. It's going to be bigger than that. Here's 180. It's going to be bigger than that. Here's 270. It's going to be bigger than that, but it's not going to be all the way to 360, right? So it's going to be somewhere past 270. So I'm just going to subtract 270 to see how far past it is. And it happens to be, what, 24 degrees past 270? So maybe something like this. So this is 294 degrees, right? And what we want to know is this angle that creates the triangle up to my x-axis, right? We need to know this angle. So if I know that this is 24 degrees past 270, I should be able to figure out how much is over here, right? Because in this quadrant, that's 90 degrees. So if I'm 24 past, I'm just going to do 90 degrees minus 24 degrees, which leaves me with 66 degrees. So this is a 66 degree reference angle, right? Because that's how many degrees take me from my terminal side up to the x-axis. Okay. All right, let's look at this next one. This one's kind of tricky. So negative 883 degrees. That's like more than one revolution, right? That actually is probably more than 2 revolutions. So I'm going to find its coterminal angle. So it's something that I can graph on a 0 to 360 plot here, right? So I'm going to go ahead and just add 360 to it to take one of those revolutions off. So if I add 360 to it, that leaves me with negative 523 degrees. That's still more than a revolution. So I'm going to add another 360 degrees. And that gives me negative 163 degrees. Okay. So negative 163 degrees tells me I'm going in the clockwise direction. And I'm going to go past 90, past negative 90, right? But not quite to negative 180. So I need to figure out how far I am from 180, right? Because I want to be able to draw it to my x-axis. So if I just take 180, and subtract the 163, that leaves me with, what, 17 degrees? So that tells me I'm 17 degrees away from 180. So it looks something like this, right? Now, when I draw this, remember I took 2 revolutions off. So this is actually negative 163 degrees. If you want to write negative 883, you need to include the 2 little revolutions we took off, right? Which would be all the way around 2 times and then this 160 degrees, right? I'm fine with you just doing this one once you've taken off the 2 revolutions, right? And what we determined is that we're left with 17 degrees reference angle right here, right? The 17 degree reference angle. Are we kind of okay? Hopefully we're not horribly offended. All right, so let's look at actually finding the trig function values now that we know how to find the reference angle. Okay, so this next problem is broken up across like a whole page and a half. So I'm not really sure why, but we're just going to do it one step at a time. Okay, so it says draw the angle 135 degrees. Well, I know that 135 is somewhere between 90 degrees and 180 degrees. Right? It's going to be somewhere in here. Now, I know I want to know the distance between that angle and 80 degrees. So instead of figuring out how far past 90 I want to go, I want to think of it more in terms of how short am I from 180. So I'm going to take 180 degrees and just subtract 135 from it. And when I subtract that, I end up with 45 degrees. So this means I'm going to be 45 degrees shy of 180. So 45 is actually right in the center. Okay. So when I draw my angle, this is 135 degrees. Okay, you will have problems like this on your exam, and I expect to see your thought process if you needed to do this. And I expect to see it drawn in standard form with the arrow telling me it goes counterclockwise and labeled with the angle measure. Okay. All right. So this is standard form going from here to here. All right. Now it says find and label the reference angle. So if my angle is over here, right, what I'm looking for is this angle right here. Right? Because I'm hoping to draw down that box. And I need to know the angle between the terminal side of 135 and my x-axis, which we already determined, right, is 45 degrees. I know that I'm 45 degrees shy here. So this is a 45-degree reference angle, okay? So on the next page, and again, I don't know why this is split up in so many steps, but I'm going to go ahead and just put it right here so I can see it. So what I have determined, excuse me, is that I have a 45-degree reference triangle. So this is 45 degrees. Okay, so now I have my reference triangle, and this is my 90 degrees, right? Now my 45, remember I told you we have to be able to know how to draw that reference triangle, right? So 45 degrees, remember the two legs were 1 and 1, and the hypotenuse was the square root of 2. So I'm going to go ahead and label 1, 1, square root of 2. Okay, 1, 1, square root of 2. So this is from what we did in section 2.1, knowing how to label the reference triangle. Okay, now the only other thing we have to take into account is what quadrant it's in. Okay, so notice we're over here in quadrant 2. So in quadrant 2, we know that our hypotenuse is always positive no matter what. In quadrant 2, our y value, or this one, is a positive, right? But we know that our x's over here in quadrant 2 are negative. So I'm going to go ahead and change this to a -1 because I know my reference triangle is in quadrant 2. All right, so now that I have my triangle labeled, now I should be able to find the 6 trig functions. So I'm going to go ahead and label sine. Sine, cosine, tangent is SOHCAHTOA. SOHCAHTOA. So for my sine, I need opposite over hypotenuse. So opposite is 1 over my hypotenuse, which is square root of 2. And then I rationalize my denominator. So square root of 2 over square root of 2 gives me square root of 2 over 2. Okay. Then I should be able to find my cosecant by taking my original sign and flipping it. So 1 over the square root of 2, when I do the reciprocal, gives me square root of 2 over 1, which is a square root of 2. Okay. Cosine is ka, right, or adjacent over hypotenuse. So my adjacent side is a -1 over my hypotenuse, which is square root of 2. And then again, rationalize the denominator, which gives me negative square root of 2 over 2. Oops. Pretend that's a 2. Sorry. Okay, square root of 2 over 2. And then whenever I do the reciprocal of cosine to get secant, instead of -1 over square root of 2, I get square root of 2 over -1, which is just negative square root of 2, right? Guess if we're going to circle one, we should circle all. Okay, and then tangent is TOA, opposite over adjacent. So opposite, my 45 is 1 over adjacent, which is -1. So 1 over -1 is -1. And if I do the reciprocal, I will still get -1. Okay, so that's pretty much the whole process. We draw our original angle, right? Remember, our original angle went from here to here. We determine the reference angle, and then we draw our triangle off of that. Then we can find all of our trig function values. Okay. Excuse me. So I would love for y'all to try the next one. And then I have a few more examples, and then that's it. Okay. So go ahead and pause the video and give this one a whirl. You're going to draw negative. Oh, this is not finding all of the trig function values. This is just finding one. Okay. So you're going to draw negative 150 degrees, figure out the reference angle, label the triangle, and then see if you can figure out sine. Okay. If you're not sure how to do it, just hang out and I will work it. If you want to try it, pause the video and see if you can get it figured out, okay? All right, so I went ahead and drew it. So negative 150 goes clockwise past negative 90, not quite to 180. It stops 30 degrees shy of getting to the x-axis. So I know that my reference angle here is 30 degrees. Now it's teeny tiny in there, so I'm actually going to draw this triangle a little bit bigger just to help me see it. So I know that this is 30 degrees. Right? And then I need to label it. So remember how we labeled our 30, 60, 90 triangle? We have 1, 2, square root of 3, right? 1 is opposite my 30 degrees. 2 is opposite my 90 degrees. And then my other side is square root of 3. Okay. Now, I have to think about the signs of these numbers because I'm in quadrant 3. So in quadrant 3, I have a negative x value, right? So this should be a negative square root of 3. And I also have a negative y value because it's below the x-axis. So this is going to be a negative 1. Okay. So now that I have my reference triangle labeled correctly, I should be able to find the sine of negative 150. Okay. So the sine value, to find sine, we do opposite over hypotenuse. So opposite 30 degrees is negative 1 over my hypotenuse, which is 2. So that means my sine is negative 1/2. Okay, and we didn't have to find all of the trig function values, so that's nice. But we could easily find all trig function values if we needed to. Okay, I'm going to do one more example of this type, and then I'm going to show you a little bit more complicated problem. Okay. All right, so this one says, draw and label the reference triangle for 780. Now 780 is more than one rotation. So I'm going to go ahead and subtract 360 degrees to try and get it down to something that's within one rotation. So if I subtract 360 degrees, that's going to leave me with what? 420 degrees, which is still more than one rotation. So I'm going to subtract another 360 degrees, which leaves me with, what, 60? 60 degrees. Yay, that worked out nice. So I'm going to go ahead and draw 60 degrees, which looks like this. And that ends up pretty nice, right? Because that makes my reference triangle or my reference angle super easy to find. Because if I draw this down to the x-axis, right, it's just a 60-degree angle. So again, like I did on the last one, I'm going to draw this triangle a little bit bigger just so that I can label it easier. Okay, I know that this is a 60-degree angle, right? And then I'm going to label it. It's a 30-60 triangle. So remember, we're using 1, 2, square root of 3. So if this is my 30-degree angle, that's my smallest angle. So across from it is 1. Across from the 90 degrees is 2. And then across from 60 is square root of 3. Okay. And then I just need to check to make sure they're all positive. Notice my angle is in quadrant 1. Quadrant 1 has positive x's and positive y's. So I just leave it like that. Okay. So now that I have my my reference triangle, I should be able to figure out whatever trig function value they want me to. Now they want me to find cotangent. Okay, so I'm gonna go back a little bit. I'm gonna think of tangent. Okay, when I think of tangent, I think of TOA. Tangent is opposite over adjacent. So if tangent is opposite over adjacent, then that means cotangent is going to be adjacent over opposite, right? Adjacent over opposite. So what is adjacent to my 60-degree angle? That's 1. And what's opposite my 60-degree triangle is square root of 3, right? And then the last thing I need to do is rationalize my denominator. So I'm going to go ahead and multiply by square root of 3 over square root of 3, which gives me square root of 3 over 3. Okay, maybe not too bad. Draw the angle in standard position, determine the reference angle, and then we can draw our reference triangle, and then make sure you check the signs of your reference triangle. Okay? All right, let's look at a little bit more complicated one. So this one says recall recall the order of operations and note that sine squared theta means the same thing as sine theta squared. Okay, so we want to evaluate sine squared of 45 degrees plus 3 times cosine squared of 135 minus 2 tangent of 225. Ha! So we have 3 different angles we're dealing with. So I'm going to go ahead and draw them so that I can figure out what their reference angle is and see what their reference triangles look like so that we can figure out these function values, okay? So the first one is 45 degrees. So I'm going to go over here and just draw a 45 degree angle. Okay, so this is what a 45 degree angle looks like. And that works out really nice, right? Because it's in quadrant 1. It's exactly 45 degrees away from the x-axis. So I can tell here that my reference triangle is a 45 degree angle, right? So I'm going to go ahead and label it. I know for a 45 degree triangle, I have 1 square root of 2. And then I just need to make sure that my signs are right. Because this is in quadrant 1, I know my x is positive, I know my y is positive, and then obviously we always know our hypotenuse is positive. So this one, not too bad. Figured it out. Now I want to figure out what sine squared is. So remember, sine is opposite over hypotenuse. So opposite my 45 is 1 over my hypotenuse, which is square root of 2. So I get 1 over square root of 2. And then notice this is sine squared. So now that I know what the sine value is, I'm going to square it. Okay? Plus, now I need to do this next one. And I'm just going to leave this. I'll simplify it in the next step. Okay, so now let's look at our next angle, which is 135. Okay, so I'm going to draw it on a different XY axis so I don't confuse myself. So 135 is not going to be in quadrant 1, right? Because it's bigger than 90 but smaller than 180. So I want to know how much smaller than 180 is it? Because I want to draw it down to my x-axis, right? So if I do 180 minus 135, what I end up with is a 45 degree. So that means it's 45 degrees short of 180. So this is what 135 in standard form looks like, right? And I want to draw it with my reference triangle, which I know is 45, right? Because it's 45 away from 180. So this is 45 degrees. And I can label my 45, right? This is my 90 degree. So this is 1 square root of 2. And then I do need to check my signs because this is not in quadrant 1. So in quadrant 2, my hypotenuse is always positive. My y is above the x-axis, so it's positive. But my x's in quadrant 2 should be negative. So that's a -1. Okay. All right, so here we're looking for cosine. Okay. Now notice this says we're doing 3 times the cosine value of this angle squared. So I'm going to go ahead and put my 3, and then I need the cosine value so I can square it, right? And cosine is SOHCAHTOA, right? So adjacent over hypotenuse. So let's look at our adjacent side here is -1 over my hypotenuse, which is square root of 2. Okay. So we're almost there. We got 1 left. So now we need tangent of 225. So I'm going to go ahead and draw my angle down here. So 225 is going to fall in quadrant 3, right? because it's bigger than 180 but not to 270. So I want to know how much bigger than 180 is, because I always draw my reference triangle up to the x-axis or down to the x-axis. We never ever draw our triangle to the y. It's always to the x. Okay, so I'm going to go ahead and take 180, or not 180, 225, and subtract 180 to see how far past 180 225 is. And it actually happens to be, ironically enough, 45 degrees past 180. Okay, so this is 225 degrees in standard form, right? But we want our reference angle, which is what we get from this triangle right here. Okay, and we know that that is going to be 45 degrees because we know it's 45 degrees past 180. So again, I want to label my triangle. So a 45 is 1 square root of 2. And then I need to make sure my signs are correct because it's in quadrant 3. So notice my x's are negative in quadrant 3, so it should be a -1. My y is below the x-axis, so it should be negative. And then my hypotenuse is always positive. Okay. So now that we have that, I need to figure out what do we need to figure out, like what trig function do we need from that. So this last piece is to minus 2 times tangent of 225. So minus 2 times whatever the tangent of 225 is, right? Tangent, SOHCAHTOA, right, is opposite over adjacent. So I'm going to look at my reference triangle. Opposite it is -1 over my adjacent value, which is -1. Okay. So now that I've got it all filled in, now I just have to simplify this. Excuse me. So I'm going to square 1 over square root of 2. Now, when you square a fraction, you square the top and you square the bottom. So when I square 1, I still get 1. When I square a square root, that cancels. So that just ends up being 1/2, right? My middle value here, when I square it, I'm gonna go ahead and leave +3, and then I'm gonna square in here. Again, when I square a fraction, I square the top and I square the bottom. When I square the top, that becomes a +1. When I square the bottom, it cancels out my square root. Okay, and then over here I have -2 times -1 over 1 is just 1. Okay. So I continue to simplify. So this gives me 1/2 plus 3/2 minus 2. Okay. So 1/2 and 3/2 gives me 4/2 minus 2. 4/2 is just 2, right? 4 divided by 2 is just 2. And 2 minus 2 is 0. Woo! That's oddly satisfying, isn't it? Or it's oddly frustrating. It always ends up being, oh man, I did all that work and it ends up being 0. Or, ooh, I did all that work and it ended up being 0. So we'll see what reaction you have. All right. So I want to show you one more problem type, and then that will be all for section 2.2. Okay, let's look at page 5. So this one says, find all the values of theta in the 0 to 360 range, meaning just in one rotation. We want to find all possible angles in one rotation that satisfy sine theta equals negative square root of 3 over 2. Okay? Okay. So let's think about this for a second. I see a square root of 3. So I already know what reference triangle it is, right? Because we have a 30, 60, 90, or we have a 45, 45, 90. And the 45 triangle has 1, 1 square root of 2. I don't have 1 or square root of 2 in here, right? I have a square root of 3. So I know that comes from a 30, 60, 90 triangle. So I'm going to go ahead and just draw a 30, 60, 90 triangle. Here's my 30, here's my 60. Opposite 30 is my one side. Opposite 60 is my square root of 3. Opposite 90 is my 2. Oh, excuse me. Okay, So I am looking for a sine, right? Sine is opposite over hypotenuse. So my hypotenuse is 2. So I need to know which opposite or which angle is opposite square root of 3, right? That's what's on top. So opposite square root of 3 is 60. So we must be talking about a 60-degree reference angle, okay? So that means theta could equal 60 degrees, right? Or it has a 60-degree reference angle, okay? Now, the other thing that comes into play is that I have a negative, right? This is a negative sine value, okay? So I got to think about, where do I get negative sine values, right? If I'm thinking quadrants, remember sine has to do with my y. So where are my y's negative? Well, it would be down here in quadrant 3 or quadrant 4. So I am looking for angles that fall in quadrant 3 or quadrant 4 that have a 60-degree reference triangle. So I'm going to go ahead and draw that. So here would be a, oh, that's like a 30. Meh. Here. Let me draw it better, okay? Epic fail. All right, so a 60 would be something like this or something like this, right? So this is 60 degrees in this direction, right? That gives me a 60-degree reference triangle in this direction. This one gives me a 60-degree reference triangle in this direction. So now that I know that these are the two terminal sides of the angles I'm looking for, I have to figure out, okay, well, what angles give me, you know, these two terminal sides. So remember, we're only looking for angles that fall between 0 and 360. So we're not looking for negative angles. So I can't use negative 60, even though I know it satisfies all of this. I only want angles that go in the counterclockwise direction. So that means I want the angle that starts here in standard position and terminates at this side, right? And then I want the one that goes all the way around and terminates here. Okay, so all I have to do is figure out what those two angles are. So this first one starts in standard position and comes all the way, and it goes 60 degrees past 180. So I'm going to do 180 degrees plus 60 degrees, and that gives me 240 degrees. So that's one answer that I get. That's this one, 240 degrees, right? And then I also want to know this one. So this one starts in standard position and it goes all the way around and it stops right here, 60 degrees shy of a full rotation. So if it's 60 degrees shy of a full rotation, I can take that 360-degree full rotation and just subtract the 60 degrees that it's shy, which gives me a 300-degree angle. So this one is 300 degrees. Does that kind of make sense? So I want to just like talk through this one like one more time so that we know what we're talking about. So first thing I did is figure out, what is my reference angle? So I looked at this to determine, are we dealing with a 30, 60, 90 triangle or a 45, 45, 90? So because of the square root of 3, I knew it was going to be a 30, 60. So I went ahead and filled out, drew and labeled my reference triangle. Because it's a sine value, I know this is opposite over hypotenuse. So if my opposite is square root of 3 and my hypotenuse is 2, that means we're looking at a 60-degree angle, because square root of 3 is opposite 60 over my hypotenuse, which is 2. So now that I know my reference angle, then I look at the sine, meaning plus or minus, of this trig function value. Because I'm looking at a negative sine value, and sine has to do with y's, I went to the quadrants where I know my y's are negative, which is in quadrant 3 and quadrant 4. Okay, and I drew the two terminating sides that would give me a 60-degree reference triangle, right? Because if I were to go in here and draw, let me get a different color. If I were to go in here and draw a reference triangle, right? Here's my 60-degree reference triangle for this one, right? And here's my 60-degree reference triangle for this one. Okay. So now that I have where those terminating sides are, then I just have to figure out, okay, well, what angles terminate at those lines, right? So I only want positive angles, so I don't have to worry about going in the negative direction. Now, they may say from 360 to negative 360, right? It could be one full positive rotation or one full negative rotation, or it could be from negative to positive. So if that was the case, I would also include negative 60 degrees, and then from here all the way over, going going clockwise. But in this case, I only wanted positives. So I needed the positive angle that terminates at this line and the positive angle that terminates at this line. I knew this one was 60 degrees past 180, so that's how I came up with that. And I knew that this one was 60 degrees shy of a full rotation, so I subtracted to find the second. Okay. I want you to work this stuff out on your paper. Okay. I know that some of these assignments have multiple choice questions, but I really encourage you not to just, randomly select until you get the right answer, because when you take your exams, this is the kind of work I'm looking for. Okay. All right. I think I just want to mention one more thing down below. So basically we have two types of angles that we're dealing with. In the earlier sections, we talked about our nice angles, right? Which is our quadrantal angles. Quadrantal angles. These are the ones that landed on an X or a Y axis. So 90 degrees, 180 degrees, 270 degrees, 360 degrees, and then, either the negatives of those or multiple rotations of those. These are nice because we can find X, Y values easily. Okay, so quadrantals are really nice because if they fall on an actual axis, it's really easy to figure out their trig function values, right? But we also now have these other nice angles, we'll call them, which create reference angles. Okay, reference angles of 30 degrees, 60 degrees, or 45 degrees. Okay, so other nice angles that we now have are 30, 60, and 45 degree reference angles because we have known trig values for them, okay, by using our reference triangle. So that's what we're going to look at moving forward. Is focusing on these ones because they're the ones we can do stuff with because we have nice values for them. Sometimes we have not nice angles, and we'll learn what to do with those later on. Okay. All right. So your first exam is going to cover sections, whatever we started with, 1.1, I believe, to 2.2. So this ends the material that will be on your first exam. So make sure you get these completed in time that you can ask questions before the exam if you need to. Okay? If you have questions, let me know.